Hi, Mr. Gibson here. We're going to get into the second lesson in this unit on sequences and series. In the first lesson, we looked at different examples of mathematical patterns and sequences, and we tried to figure out what the rule is for that. Today, we're going to look at one specific type of pattern or rule called an arithmetic sequence. So let's look at our objectives for today. The first is, how do we identify or recognize that we have an arithmetic sequence? And then the second is, how can we generate one if we're given certain information? And that information could include, the two types of formulas that we introduced in the first lesson, a recursive or explicit formula. So we'll look at what do those formulas look like for arithmetic sequences. The last thing we'll look at is something called finding the arithmetic mean, or using the arithmetic mean to find a missing term, okay? And it's quite a simple concept. When we get to that, it'll make a little more sense in the lesson. All right, so let's start by just looking at these patterns here. I'm going to leave this on the screen for a second so you can look at them and see, and just do this right in your notes, if you can describe the pattern in each one of these, right? Just like we did in the first lesson. So pause the video, see if you can figure these out. All right, let's try these together. So the first one, 10, 8, 6, 4, 2, 0. That one, pretty obvious that we are subtracting 2 each time, or the difference between the first term and the next term is -2. Okay, subtracting 2 or adding a -2 is the same thing. Let's look at B. We have 5 over 7, 8 over 7, 11 over 7. So it has the same denominator, but the numerator is changing. How much is it changed by each time? Well, it looks like we're adding 3, right? So in this case, we're adding 3/7 to get to the next term. Let's look at C. 3, 16, 29, 42, 55, 68. Maybe not quite as easy on the mental math, but we could always subtract the previous term from the next term to see what the difference is. So 16 minus 3 gives us 13, and we see that that's what we're doing for each term, adding 13. One more here, -4, or -1/4, -1/2, -3/4, -1, -5/4. Now, these don't all have the same denominator, but what if we did change them to be a common denominator, say of 4, right? Then the 1/2 would become 2/4. So then we would start to see a pattern here, 1, 2, let me get my pointer on, right? If we were to change this to 2 over 4, and -1, we could write it as -4 over 4. Okay, so now the pattern becomes a little easier. 1, 2, 3, 4, 5, all negative. So in this case now we are subtracting a -1/4. Okay, so what do we notice is common about all of these sequences? We're all either adding or subtracting a constant value, okay? So let's put this together in the next step. Let me clear. What do these patterns have in common? We just talked about that, right? Each changes by a constant amount, either addition or subtraction. All right, so let's define what an arithmetic sequence is. It's a sequence where the difference between consecutive terms is constant, okay? And we saw that, right? We came up with that constant value, but this is the key, that we're looking for a difference between consecutive terms. So consecutive just means one after another. And as long as that difference is constant, we have an arithmetic sequence. And we call that difference the common difference, okay? Common just because we see the same value each time. So let's look at a couple more examples here, and I want you to determine, do you think they are arithmetic sequences? If so, what is the common difference? Okay, so pause the video, take a look at these, just say yes or no. It's an arithmetic sequence. If it's yes, then what is the common difference? All right, let's go through it. 2, 4, 8, 16. Is there a common difference? Well, how are we getting from one term to the next? We're multiplying by 2 each time, right? 2 times 2 is 4, 4 times 2 is 8. So in this case, we don't have a common difference. We have a common factor we're multiplying by, but it's not a common difference. How about the next one? Yes, right? 7, 3, -1, -4. Each time we are subtracting 4. So in this case, the common difference is actually a -4. Okay, a good way to think about how to find the common difference is, what would I have to add in order to get to the next term? And in this case, subtracting 4 is the same as adding a -4. All right, let's move on. C, -2/3, 1/3, 4/3, 7/3. So in this case, yes, we're adding a 1, or you could think we're adding 3/3, right, to each term here. So our common difference would be 1. All right, how about the next one? They're not numbers, but they're dots, so we could simply count the dots, right? We have 3, we have 6, we have 10, we have 15, okay? So is there a common difference here? Well, here's how we do it. The difference here is 3. From 6 to 10 is 4. From 10 to 15 is 5, okay? So the answer here would be no, right? We don't have a common difference. It looks like the pattern would be, we first add 3 and then we add 1 more each time, but definitely not a common difference. So this would not be an arithmetic sequence. All right, let's look at the 2 forms of the equations for an arithmetic sequence. Okay, now we talked about these in the first lesson. Remember, the recursive form is used to tell us the next term. Okay, so we have to know the previous term in order to find the next term. So that's what this is telling us right here, right? We are going to take, to find the nth term, remember n just represents any number of along the list of numbers in our sequence. And if we want to find that nth term, we take the 1 before it. So n-1 means back up 1 term and add our common difference, d. Okay, d stands for the common difference. And then we always need to include a1 in order to complete this formula here. Or if we're going to generate the sequence using the formula, we have to know our starting point, okay? D in both of these equations, as I mentioned, is the common difference, okay? So if we're adding, it's going to be positive. Let me write this in here. So if we're adding, right, it's going to be positive. If we're subtracting, not very good at doing this with my mouse. Okay, but if we're subtracting a constant value, right, then the common difference will be negative. All right, explicit, remember, allows us to find any term in the sequence without having to know the previous term. The only thing we do need to know for this formula is our starting point. So similar to recursive, we do need to know the first term. But then we just add to that the term we're trying to find minus 1, and then multiply that by our common difference here, okay? So make sure you get these formulas in your notes. You're going to use them a lot today in this lesson. So let's look at some more examples here, okay? We want to write the first 4 terms using the recursive formula, okay? So here's our recursive formula. It's given to us, right? It's to find the nth term, we take the 1 before it, and in this first case, we're going to do what? We're going to subtract 6, right? So that's our d value, our common difference here. We can pick that out of the formula. So the first term is 18, so each time we're going to then subtract 6. So let's do that. It would be 18, and then minus 6 gives us 12, minus 6 gives us 6, minus 6 gives us 0, etc. Okay, let's do the next one. What is our common difference? Well, here it is right here, plus 10, right? So we're going to add 10 each time, starting at negative 5. So negative 5 plus 10 would give us a positive 5, and 15, and 25, and so on. All right, let's do one more with fractions. Yeah, don't worry, fractions will not hurt you. So we're going to start with 1/4, and each time we're going to add 3/4 to it, okay? And it's okay to just leave it as what I call an improper fraction. You don't always need to convert it to a common or a proper fraction, okay? So here's what it would look like. 1/4, and then we add 3/4 would give us, right, 4/4. I did change that to 1, but you can leave it as 4/4. And then if we add 3 again, right, we're going to get 7/4. Now I changed that to 1 3/4, but you can leave it as 7/4. And if we add 3 again, right, we would have 10/4, right, which is the equivalent of 2 1/2. But these are okay. You can leave it as a improper fraction if you have a fraction as your terms. All right. Let's do the same thing, but now we're going to use the explicit formula. Okay, so, and notice I'm just having you find two particular terms, the 5th term and the 9th term here, right? So to find the 5th term, we're simply going to put into n, right? N is the variable in our explicit formula. We're either going to put in 5, right? Or we're going to put in 9 to find the 5th and the 9th term. So what do we, well, let's do that. If we put in 5, 5 minus 1 is 4, 4 times 3 is 12, plus 4 is 16, right? That's where we get the 16. Let's put in 9. So 9 minus 1 is 8. 8 times 4 is 24. Add 4 more, and we get 28. Okay, so you're just plugging in the value of n based on which term you're trying to find. Okay, so but and in the rest of these problems, we're doing the same thing. We're trying to find it for n equals 5 or n equals 9. Okay, so go ahead and do these in your notes. Pause the video. Okay, so if we put in 5, 5 minus 1 is 4, times negative 2 gives us a negative 8. Negative 3 and negative 8 gives us negative 11. If we put in 9, we get 8 times negative 2. That's a negative 16, and we get negative 19. Same thing for the last one. We're going to put in 1. A little bit trickier with fractions, right? But I'm sorry, we're going to put in 5 and 9. Same thing. So we'd have 4 times 1/3, which is 4/3, and a negative 2/3 gives us a positive 2/3. We put in 9, we get 8/3, and then subtract 2/3 gives us 6/3, which is equal to 2. Okay, so there's some examples of using the explicit formula. Now, one last thing here, the arithmetic mean of any two numbers. It's simply the average of the two numbers. Okay, so if you're trying to find their arithmetic mean, and mean is a statistical word that means average, right, in our everyday language. So think of this as the average of the two numbers. How do we take the average? We add them together and divide by the number of values. In this case, we have 2 values, so we're going to divide by 2. So we can use that to find a missing term of an arithmetic sequence. Let's look at an example. If we have 3 terms here, 84, and then the missing term, and then 110, how would we find, right, this missing term? Well, we're going to find it using this arithmetic mean. So we're going to add 84 and 110 together, and then simply divide by 2. And if we do that, we see we get 97. Whoops. So 97 would be our missing term right here. Okay. All right. So that's really it in terms of the lesson. We'll look at a few more examples here in a minute, but we did 3 things, right? We know how to identify an arithmetic sequence. It has a common difference. We know how to generate sequences using either their explicit or a recursive formula. And then the last example we looked at is how to find the arithmetic mean, or think of it as the average, to find a missing term, okay? All right, so your notes are complete, but let's get a few more examples that will help you with the homework today. Okay, so we don't have whiteboards at home, but you can just do this on scratch paper. But in class, if we were together, I do a lot of whiteboard work and we do these. All right, so same question we did at the beginning, right? Is this an arithmetic sequence? So I'm just going to pause for a second on these problems, give you a chance to pause the video and work it out, and then show you the answer. All right, let's look at the next one, 0, 1, 3, 6, 10. Notice I'm finding the common difference, subtracting one term from its previous, right? 10 minus 6 gives me 4. Okay, so neither of these so far are arithmetic. Let's look at some more. In this case, yes, we're adding 4 each time. Yes, in this case, we're subtracting 1/2, or our common difference D would then be a negative 1/2. All right, let's find the 32nd term of each sequence. Now, before we can do that, we don't want to have to write out all 32 terms here. So which formula would we use, right, if we want to find the 32nd term, not just the next term, but the 32nd? Well, we need to find the explicit formula. So to do that, right, we need to know the first term and our common difference. So we look here and see that our common difference is 3. So now we can plug it in, right? Remember, this is A1. So we put in 34 for that. Our common difference over here is 3, and then we multiply that by this expression n minus 1. Okay, go back and look at your notes. You'll see the form for the recursive formula. So now it's just arithmetic, right? We plug in 32, since we're looking for the 32nd term here. Okay, so that's what I've done over here, put in 32, and then go ahead and do the arithmetic. Just make sure you follow order of operations. Okay, let's try a couple more of these. All right, first term is 3, common difference is negative 2. We plug all that in, we find negative 59 as our 32nd term. It makes sense it's negative, right? Because look at these numbers, they're getting more and more negative. All right, one more. All right, first term is 13, common difference is 4. And now we do the arithmetic, we get 137 as our 32nd term. All right, a couple more here. Let's find the missing term using the arithmetic sequence. So remember, we're just going to really take the average, add the previous term and the following term, and divide by 2. So if we do that, we get 13. Okay, let's do a couple more. 101 and negative 115. Works the same way, just be careful with the negative. Now this notation looks a little different, right? Instead of kind of doing a dot, 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 and commas, notice I'm saying the term before the 1 we're finding, so n minus 1 is 100, and the term after the 1 we're trying to find, n plus 1, is 140. So this is the same, really, as writing it as this way, right? 100, and then our missing term, and then the following term, 140. So it's just a different way using this notation. Okay, same process though. We're going to add them together, divide by 2. We get 120. And let's do one more. Now we have 3 here, a little bit of challenge. See if you could figure out how to do this. All right, so let's find the middle term first, right? If we do that first, then we can find the other two that are in between two other terms. So 65 and 81 divided by 2 is 73. And then we can repeat the process to find the other two. All right, one more problem here. Find the 17th term of each sequence. Now, which term did I give you? I gave you the 16th term, okay, the one before it. And I give you the common difference. So all we have to do to get from the 16th to the 17th term is add 5, okay? Or basically use our recursive formula, okay? So simple once you understand the notation here. Let's try another one. But notice now, which term am I giving you? I'm giving you the 18th term, which is the one after the one we're trying to find. So if normally we would subtract 4 to get to the next term, we would do the opposite of that to get to the previous term. So we would add 4 to that, okay? Now we can still kind of use the formula here, right? But notice the two negatives give us the positive here. We're going to subtract to get back to the previous term. So in the homework, be careful. You got to look closely to see, am I being given the previous term or am I being given the term after what I'm trying to find? Okay. All right. One more example here. Write an explicit and recursive formula for each sequence. So we have to find the common difference in our starting point, and then we can simply write the formulas using our notes here, right? Here's the explicit and then the recursive. Don't forget in the recursive to always give the starting value. Okay. All right, one more. See if you can do this. All right, first term is -4, recursive, or the common difference is also -4. So here's what our formulas look like. All right, that's it for today's lesson. You'll find a worksheet with some problems on it. Go ahead and work those out on your own paper, and we'll review those in our next class.